So let's get started training a logistic classifier. A logistic classifier is what's called a linear classifier. It takes the input, for example, the pixels in an image, and applies a linear function to them to generate its predictions. A linear function is just a giant matrix multiply. It takes all the inputs as a big vector that will denote x, and multiplies them with a matrix to generate its predictions, one per output class. Throughout, we'll denote the inputs by x, the weights by w, and the bias term by b. The weights of that matrix and the bias is where the machine learning comes in. We're going to train that model. That means we're going to try to find the values for the weights and bias which are good at performing those predictions. How are we going to use those scores to perform the classification? Well, let's recap our task. Each image that we have as an input can have one and only one possible label. So we're going to turn those scores into probabilities. We're going to want the probability of the correct class to be very close to 1, and the probability for every other class to be close to 0. The way to turn scores into probabilities is to use the softmax function, which I'll denote here by S. This is what it looks like. But beyond the formula, what's important to know about it is that it can take any kind of scores and turn them into proper probabilities. Proper probabilities sum to 1, and they will be large when the scores are large, and small when the scores are comparatively smaller. Scores, in the context of logistic regression, are often also called logits.